one oxygen is not good. One oxygen is connected to carbon monoxide. That's a bad word. You don't want to have carbon monoxide in a closed garage with your engine on. That's not good. Like that. So too little oxygen, bad news. O2 is what we live by. O3 is hyperactive. So there you have it. So oxygen have all this chameleonic position. So we want O2. But it is possible that 1 in 10,000 oxygen will go haywire, and when it does, it's going to go after double bond of unsaturated fat, and it doesn't screen one from the other. If it happens to be linoleic acid with C18, it goes after that. If it's fish oil omega-3, it would go after that, like that. But then at the same time, we cannot eat a lot of palmitic acid and stearic acid, which is saturated. If you do, then the cell wall is unable to be pliable, and then so the gated community is almost like the drawbridge doesn't come down. Just think of a castle, like it just doesn't come down. Well, if it does, because it's creaky, it just doesn't. If it doesn't come down, well then things cannot go in and things cannot go out. That's not good also. So I would say, because we are kind of out of kilter by taking too much 18 carbon fatty acid, more of C22 and C25 is good, and they seem to be found in marine organisms, whether it's crustacean or fish. Fish is just an easy, inexpensive way to consume. The very few antioxidant the body makes are these. CoQ10. CoQ10 is a true antioxidant, and the body makes it. So for whatever that is, that's something to take note of. Another one is glutathione. People call this a master antioxidant. I don't know if a master it's more a claim that an antioxidant, yes. And it's a 3 amino acid together like that. So that's that one. In women, before menopause, they make estrogen. And I look at the molecule of estrogen. Estrogen is an antioxidant, which is why I am under the curiosity that after menopause, women have more oxidative challenge. The plant makes this because in the plant does not have huge amount of fat, because most of the plant don't look like avocado. They don't look like the fat in coconut. They don't look like that. They just look like, think of spinach, think of cauliflower, think of things like that. Think of EGCG in tea leaf. What fat? There's nothing there. So they are supposed to protect the cell. So in the cellular thing, which is low in fat, many of these polyphenols kicks into action. However, when it comes to human being, we are overweight, and we are obese. We have other problems that are definitely fat related. So if that is the case, we need less of polyphenolic protection, like the polyphenols will protect the leaf. We will need the kind of antioxidant protection that would protect the vegetable oil, the avocado oil, or inside the seed where the fat is. Think about that. This is how the plant makes it. So if that is the case, then the antioxidant we need, they mostly look like vitamin E molecule. Now, I have a structure here. That is a structure of tocotrienol, like that. If I purposely go out of screen, see that? The black color is carbon, the white color is hydrogen. That is totally hydrocarbon. That means it sticks deep inside the fat, the fatty acid of the phospholipid. If I come closer to you, you see that there are 3 points where there's like an O-ring. That's a 3 double bond, and hence triene. Now, if I go the other side, that's the antioxidant. That's the phenolic ring, and that's the antioxidant where my finger is pointing. So if you have this thing here, this one here is seated deep inside the phospholipid, and this one here is outside the cell wall. And if it's an oxygen radical come in, it zaps it. if the oxygen radical get into the double bond, it opens up, take the oxygen and come out like that. The molecule that is an antioxidant in the fat has to look like this.